In this lesson, we're going to work on comparing and analyzing line plots and stem and leaf plots. Here's our I can statement or our objective. I can compare and analyze line plots and stem and leaf plots to identify their similarities and differences. When we look at these, we're also going to review how to find mean, median, mode, and range by using a stem and leaf plot or a line plot. The first question says, which plot correctly represents this data set? We have a lot of numbers here. The first thing I notice, thankfully, they are in order already from least to greatest. Check it out. If they were all mixed up, that would have made this question a lot more difficult. So we have a line plot as well as a stem and leaf plot. Let's take a look at the stem and leaf plot first. Our key shows that 6 separated by a line and a 7 is equal to 67. So that means that all of the stems, which remember are in front of that line, are representing the tens position. And then all the leaves that we see are representing the ones position for place value. So when I take a look at this, the first number is a 4 and a 0, which is 40. So far, so good. 4 and a 5, which makes 45. So far, that's correct. Now I'll look at the 5. 5 and a 0 is 50. Then I should have 3 5s in the one spot, which makes 3 55s I should see in the data. So when I go up here, 55, 55, and they're missing. So right now I know that because it does not have 3 55s, this stem and leaf plot is not accurately representing that data. There's only 2 of them. So now just to double check, that means that this one, our line plot, should be the correct answer. Let's take a look. We had one test score of a 40. There it is. 45, I should have 1, and we do. 50 is represented with 1. We do have 1 50. Remember, we're looking for 2 55s here, and so far so good, it's correct. For 60, there should just be 1, and there is. 65, there's 1. For 70 test scores, we should have 1, 2, 3, 4. 1, 2, 3, and 4. So again, that's good. 75, there isn't an X there. So no one got a 75. And when I double check my list, that's correct. No one received a 75 on the test. My next number is an 80, 180. I should have 2 85 test scores. We do. How many students received a 90? According to our line plot, we have 2, and that's verified up here on our list. Finally, perfect scores, 100. We have 2 of those, which is represented here. Okay, for this next question, it says, are these plots the same? If not, what's the difference? Number of jumping jacks is the title of both, so far so good. Let's take a look at our key for our stem and leaf. 6 separated by a 7 is equal to the number 67. So just like our last example, we have on this side, our stem is going to represent the tens. On the right-hand side of that line is going to be the ones position. So we have lots of jumping jacks, it looks like people have done. I'm going to look over at this one, and I'm going to start comparing. So I'll start with my stem and leaf. This first number is a 4 and a 0, which is 40. There's only one of those, and there's only one of the 40s represented over here. My next number should be 42. There's only one of them. There is also only one of those represented on the line plot. My next number in the stem and leaf is 48 jumping jacks. And it is represented here. If you take a look, this is probably a little bit different than ones that we've seen before. This line down on the bottom, that number line, it's going by a scale of 2s, which is okay. It can be by a scale of 2, which makes this right here in between a 48 and a 50 have to be 49. And we do have a 49 on our stem and leaf plot. Now we're in the 50s. So 54 is the first number. Here it is. We should have 3 55s. So 3 people did 55 jumping jacks in whatever time limit it was. And we see that that is represented here as well. And again, it's in between 54 and 56. So 55 would be right here. We are up to 58. We do have one represented here at 58. We have one person who did 59. Again, in between 58 and 60 would be 59, and we have one X for that one person accounted for. Taking a look at our 60s right now, we have 61 as the first number. That odd number again is right in between 60 and 62, and there's only one of them. For 62, we have 2 62s. So I'm going to look above. Here's 1, here's 2. Next number, 63 jumping jacks. So another one in between, and here it is. We should have 66 next. Here it is. Our next number would be 69. So when I look in between 68 and 70, here it is. We're down to the 70s, or I should say up to the 70s. We have how many people who did 70 jumping jacks? 2. When I go to 70 and I look, 1, 2, they've got 3. So here's the difference right now. Because I found one thing different, I can now finally answer that question. No, they are not the same. Might as well go ahead and finish it out since we were so close to comparing. We already know that the number 70 has different data results. Remember, it's quantitative data versus qualitative data. And for 72, there should also be 2. So that's another difference. So what's the difference? It would be that the data represented for 70 as well as 72 jumping jacks is different on both of these plots. All right, for this one, it says this data set represents the amount of money 2 sisters earned babysitting. Which plot correctly displays this data set? I am going to keep my fingers crossed right now that when I'm looking at the amount of money the girls made, that it's in order from least to greatest. And I'm really happy right now because thank you, it's already in order. I don't need to worry about that. Looking at our stem and leaf, it looks like, as usual, which what we've been practicing today, we have the stem representing the tens, the leaves are representing the ones place value position. So that 4 separated by the line 5 is equal to 45. And in this case, remember we're talking about money, so it'd be $45. So when I look back up, I'm going to start with this one first. I should have 2 times where they only earned $5 each. They must not have been babysitting very long. Therefore, we have a 0 in that 10 spot. And there are 2 5s here for the $5. The next number we have is 10. So all the numbers in the teens, of course, are going to be represented in this particular stem with their leaves. So we have 110. I'm just going to place a dot on it. And I should have 3 15s. So when I look back up, 1, 2, 3 15. So far it matches. Let's start with the 2 in the 10 spot. So according to the list up top, the next number should be 20, and then we should have 2 25s. So here is a 2 and a 0, which is 20, and then we do have 2 25s. Moving on to the 3 in the stem position, or the 3 in the 10 spot, I should have 3 30s, which means when I look down here, I'm going to have 3 zeros. So here they are. And then 1 5 for 35 is also here. So far, this one's accurate. We should now be going to a 4 in the 10 spot. And that's what they did after that 35. So according to my list up here, I have 2 $40 amounts. After the 40s in the list, we have 2 45s. And that is also accurate. Hop into the 5 right now for the $50 amounts. There should be 2 $55 amounts represented. So here it is, a 5 in the ones as well as a 5 in the ones. Now I'm up to 60. Oops, I see a difference. Our stem and leaf has 2 60s represented. This line of data up top only shows one $60 event. So this one is not accurate. Once I find that one thing that's different, I can eliminate it. I don't need to check anything else. Therefore, this should be working. Let's check it to make sure. For 5, we have 2. I'm going to change my color. And we do have the 2. 10, there should only be one of those, and there is. 15, there should be 3. And there are. Then we skip to 20. There's only one of them. For 25, we should have 2. 30, there should be 3, and there are. 35 is 1, and here it is. 40, we should have 2 X's. Good. For 45, we should have 2 X's as well. And here they are. Looking like this is going to work. 55, there are 2 X's and there are 2 events. Then for 60, there's only one. Good, there's only one here. So this is one that's looking good. And then 2 65s. So our line plot is the one that correctly represented that data set. Something to be really mindful of is a lot of times if you have a question like this, you're going to have to check pretty far into your line plot or your stem and leaf because the error will occur towards the end. If it was up here, if there was a mistake up here, like there were 2 zeros for 2 10s, then that would be super easy on us because right away we would know that that did not accurately represent the data.